A few years ago, investors were asking a lot of questions about artificial intelligence and machine learning. And a few years ago, the developers were building these technologies really from scratch. And since then, a lot of large companies, examples being Microsoft, Amazon, Google, have invested in some very powerful AI technologies. Google's TensorFlow, Microsoft's Azure ML, Amazon's machine learning platforms, to enable developers to build artificial intelligence into applications. And just as the whole world of DevOps was created, where developers used to have to lower the gap to take an application from development into production, well, the same is true for machine learning. So one of the companies we looked at recently, called Brightlight in London, actually has developed something called MLOps, which is like DevOps. It allows you to build models for machine learning in development and then test them and move them to production quite efficiently, and actually tune and improve the models, because models don't just stay static, they improve over time. And as you improve them, you want to move them to production. So there's this new emerging area called machine learning operations, or MLOps, which is, you can think of as DevOps as an equivalent. When it comes to maintaining the models are built using machine learning, which is either supervised, where you give the application a model, a basic set of data, unsupervised, where it imputes the model from the data, and then there's something called recursive learning, where the model gets maintained over time. When you maintain these models, it's actually very, very critical to not change the core model too much, but really maintain the model at its edges. So you're looking for edge cases with which to train the model. And a company in France called Deepomatic has a very good platform for doing that, where they do industrial type models and in industrial applications using video and control systems. And they have really mastered the art of not only deploying new models to the edge from the core model development platform, but also maintaining those models in production by really just focusing on edge cases, so they don't have a catastrophic maintenance event and kill the model. Another good example of that is a company visited lately in the Bay Area called Talos. Talos is a company that does robots. It makes robots, and the robots are controlled by AI and ML models, but the robots are taking visual input from cameras in the environment that they operate in. They operate in manufacturing environments. So they are, if you think of these robots that assemble cars and put things together, these are the kind of robots that Talos has figured out how to create a very easy way to program and take advantage of artificial intelligence to essentially eliminate the very mundane task of assembling things. There are a lot of emerging applications that are coming into light. And a good example is one from a company in Grand Rapids, Michigan called CRI, where they've come out of the government sector, so they did a lot of drone defense and drone surveillance, and they have developed on-camera intelligence using AI models that can actually look at non-visible spectrums. So if you think of protecting rare or endangered species like grizzly bears or other types of rare species from forest fires or from other types of dangers, they're able to actually identify a grizzly bear from several thousand feet up, because of the oils on its fur actually project a type of electromagnetic radiation that is non-visible. So it's using very advanced cameras to see things that you can't normally see using visible light, and be able to distinguish between different types of animals or different types of objects on the ground, and then track those objects as they move around. Another example, they've been used to actually solve arson crimes and some other types of very high, very difficult to do detection and analysis using very high resolution imagery. Another application is one that I really enjoyed learning about. There's a very famous electric guitar manufacturer, his name is Paul Reed Smith, and he developed an application that takes advantage of signal processing and the artificial intelligence that you can apply to that. And he's applied it to healthy and cancerous cells, so that he can actually detect a different sound from a cancer cell than he can from a healthy cell. And he's currently raising money to really proliferate this technology into the healthcare industry for cancer detection. So we're going to be seeing a lot of very powerful applications that take advantage of artificial intelligence and machine learning as developers become much more familiar with the tools and can embed artificial intelligence and machine learning into these new applications that deliver massive efficiencies to industry and also consumers in the future.